Okay, in this lesson, we're going to be using the law of cosines. The law of cosines can be used to find side and angle measures giving these two scenarios, a side angle side or a side side side. Or again, I like to just say, try law of sines. If law of sines doesn't work, then try law of cosines. One or the other is going to work. Now, here's your law of cosines. There's actually three of them. But technically, they're all three the exact same thing. A squared equals b squared plus c squared minus 2 times b times c times the cosine of a. Or you can just rearrange everything. B squared equals a squared plus c squared. And notice all I'm doing here is I'm flip-flopping my a's and b's. So this would be minus 2 times a times c times the cosine of b. Or my last one, c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. And you could actually get by with only using one of these by flip-flopping some values around, and we'll show you how to do that as we go. So let's use some law of cosines. Find each side length, round the answers to the nearest tenth, the first issue. Okay, so which one do we use? Well, any of the ones that you want. Just label this angle as angle A, angle B, or angle C, all depending on what you want to use. So if we want to use our first one, the first one involves angle A over here. So therefore, let's label the angle that we know, angle A. Then the other two angles could be our B and C. And a reminder that, let me go back here, angle A and side A are across from each other, angle C and side C are across from each other, and so are the B's. So the law of sines, here it is. Or excuse me, not the law of sines, the law of cosines. Here's your law of cosines. Now let's plug in everything we know. Our A value, our small a is our x. Our small b value is 28, so is equal to 28 squared plus our small c is 16. So everywhere you have a b, let's put a 28. Everywhere you have a c, let's put a 16 times the cosine of angle A, which is 127 degrees. Let me erase that 7 right there that I accidentally put. So it's simply type all this in your calculator. Now I do want to point something out as we type this in. There are three terms over here. 28 squared is a term, 16 squared is a term, and this whole last thing is a term. So as you type it in, you're going to get x squared is equal to 1,579.2263. And the last step to get rid of a square, you do have to square root that. We do not have to put plus and minus because it's a triangle and we can throw the negative out. So therefore, we're only worried about the positive. So our x value is going to equal 39.7 inches. Number 2. Again, it doesn't matter which formula we use. If we want to call this A, we can use our first formula. We can call it B and use our second formula. It doesn't really matter. So we'll do it like this. If you have angle B, then we're going to use this formula. And again, if you flip-flopped and you wanted to put angle A where the 36 was, that's fine. And you use the different formula, which is pretty much, again, the exact same formula. Let's plug in everything we know. We're missing our small b. So we're going to have x squared equals. Our small a is across from angle A, so 25 squared plus small c is 12 squared minus 2 times 25 times 12 times the cosine of angle B, which is 36 degrees. Again, three terms, square it, multiply it all together. And you're going to get x squared is equal to 283.5898, 283.5898. To get rid of a square, we're now going to square root, and you should get x is about 16.8, and that is in miles. And again, why use the law of cosines here? You could try the law of sines, but there's a problem. You have an angle, but you don't have a side across from it. That's the only time you can use the law of sines is when you have an angle and the side that's across from it. Okay, the next one gives you the description but doesn't draw the triangle for you. So let's kind of draw it. So you have A, B, and C. It says that angle C is 88 degrees. AC is 22 feet. And BC is 11.5 feet. And notice you have an angle but not the side across from it, so it has to be law of cosines. Since you're given angle C, then we're going to be using the third formula. And there it is. Now let's plug in everything that we know. Our C value, which is what we're looking for, is unknown. So we have x squared is equal to, our little a is 11.5, so 11.5 squared, plus b is 22, so 22 squared, minus 2 times 11.5 times 22 times the cosine of angle C, which is 88 degrees. Work out these three terms, and you're given that x squared is equal to 598.5909. So therefore, to find x, we're going to simply square root that, and we're going to get 24.5, and that was in, let's scroll back up and look at our problem, that was in feet. Okay, next up, it says finding angle measures. Now, angle measures are going to be a little bit more difficult. A couple of different ways you can do it. Now, on the first one, I'm going to show you how to actually work these out to find the angle measure. So I'm going to let this be my A value. If I'm looking for my angle A, then I'm obviously going to use my first formula. That's the one that involves the angle A, so here it is. And this is the reason I've been so adamant about telling you that there are three terms over here. It's going to become very important in this problem. So let's plug in everything. Small a is 10. Small b, well, let's label this. Doesn't matter which is which. Small b would be 13, and small c would be 11. So minus 2 times 13 times 11 times the cosine of a. And we're looking for what is a. So look what we've got to do. To solve this equation, I have 1, 2, 3 terms on the right side. My first step is to take the 13 squared and the 11 squared and move it to the other side. Since they are terms and they are both positive, I can do minus 13 squared and minus 11 squared is equal to negative 2 times 13 times 11 times the cosine of a. Now, a lot of people are tempted in typing this into their calculator and hitting enter, and that is very wrong. The reason why is this 13 squared and this 11 squared. Sure, go ahead and type it in and add them together, but you can't subtract this because this is kind of like, look at this. Here's an example. What if I ask you to do 3 plus 4 plus 5x? Can you do 3 plus 4 plus 5 and just put the x afterwards? No, you can't. They're not like terms. These are like terms and can be added. That's 7. However, you can add 5x to that. The exact same scenario is here. You can add these two together. They are like terms. But this has a cosine a attached to it. So therefore, they cannot be added together. So how are we going to get a cosine of a by itself? Notice that this stuff is being multiplied by the cosine of a. So therefore, to get rid of these, since they're being multiplied, you're going to come over here and you're going to divide by negative 2 times 13 times 11, and that gets rid of that. So we're going to type all this stuff in, and you get 0.6643 is equal to this, the cosine of a. So we've actually got one more step. We've got to move this cosine over to the other side by doing the inverse cosine. Now, what's nice about this is we don't have to worry about that whole first quadrant, second quadrant stuff because all students take calculus. If we have a cosine that is positive, we have to be in the first quadrant because down here, these are angles between 270 and 360. That's the other place where cosine is positive. This angle cannot be between 270 and 360. So we know that our answer is a first quadrant answer because this is a positive cosine value. When you do the inverse cosine of 0.6643, you get a value of 48.4 degrees, and that is the only possible answer. Okay, let's do one more like that, and then again, I will show you the shortcut. Looking for this, we'll call it angle B, just to use a different formula here. Since we're dealing with an angle B, here's the formula you're going to use. Now let's take all the values and plug them in. We'll call this an A and a C here. So small b is 17, so 17 squared equals angle A is across from 18, angle C is across from 30. So you have 2 times 18 times 30 times the cosine of angle B, which is what we're looking for. And you could put an x there if you wanted to. Move these two terms over. So now you have 17 squared minus 18 squared minus 30 squared is equal to, don't forget this negative when you're writing it down. Leave that negative there. Negative 2 times 18 times 30 times the cosine of b. Now, if you wanted to clean those up by multiplying, that's fine. But I like to go ahead and just divide by negative 2 times 18 times 30. Type all of this into your calculator, and you get 0.8657, and that's equal to the cosine of B. To get rid of a cosine, we're going to move it over here by doing the inverse cosine. And that's going to tell us that our angle B is equal to right at 30 degrees. So let's go back, and now let me show you another trick for another way that you could work this. If you take these formulas, and remember how we've been solving these. We've been taking this term and moving it over. Then we've been dividing by this and doing all that work. Well, you could actually do that to begin with. Let me find me a blank space here. Let's take our formula. And you could actually do this for any of the three formulas. I'm just going to do it for the one just to show you. And let's go ahead and move these two terms over in our formula. Let's do a squared minus b squared minus c squared is equal to negative 2 times b times c times the cosine of a. Let's get rid of this term, or not that term, but that's that coefficient, I guess you could say. Since it's being multiplied, let's do the same thing we do in our problems. Let's divide by it. So now what you have, that got rid of this. You have the cosine of A is equal to that stuff. So you actually have created a new formula. And if you'd like to, you could actually go a step further. And you can say, you know what, to get rid of the cosine, I've actually got to move it over by doing the inverse cosine. So you could actually say that angle A is going to equal the inverse cosine. That's how you move that over. The inverse cosine of A squared minus B squared minus C squared over negative 2BC. And if you do it that way, in order to find angle A, you can type this whole thing into your calculator and you're finished. Just make sure that since it is a fraction that you put the top in parentheses and you put the bottom in parentheses as you're typing it in. So that's another way of working these. So we might try to use that on this next one. It says in triangle RST. Now that's weird. We don't have any R's, S, and T's in our formulas, so we might have to change some stuff up here. But in angle RS, or in triangle RST, RS is 9, ST is 14, and RT is 6. Find the measure of angle R. This is our unknown right here. Well, again, that doesn't match our formulas. That's fine. Erase these letters and put any A, B, and C letter you want to. We'll call this A, we'll call this B, and we'll call this C. That way it matches our formulas. It doesn't matter what the angles are called. As long as we understand this is the angle we're looking for. So, again, in order to do that, I can actually do it the way I just showed you. We can take and manipulate our formula and figure out what this is equal to. And here's where I solve my formula for A. And there it is. And now we can simply take and plug our information in. So our angle that we're looking for will equal the inverse cosine of, on top, we're going to do A squared, which is 14 squared, minus 6 squared, minus 9 squared. And as you type that in, make sure you put it in parentheses, over negative 2 times B, which was 6, times C, which was 9. Make sure you put that in parentheses. You can type the whole top in, divide it by whatever that is multiplied, find the inverse cosine of that, and you can do that. You can type the whole thing into your calculator now, and you're going to get that angle A, which is the missing angle, which is actually our angle R, is equal to right at 137 degrees. Much faster. Number 7. Two ships, these are applications, and again, notice a bearing, make this note, a bearing measures the acute angle that a path or line of sight makes with a fixed north-south line. So what that means is, if you were to draw a north-south line, if you go, let's say that you're traveling at a bearing of south 30 degrees east. Okay, we're going to go south, and then we're going to go 30 degrees east of south. So we're going to go kind of this direction to where this is 30 degrees. Or if it was north, 40 degrees west. North would be this direction. Well, that's going to be 40 degrees to the west of north. So this would be 40 degrees here. So that's what that means. So two ships leave a port at 8 a.m. Ship A sails with a bearing of north 68 degrees east. So let's draw that. Let me draw my north-south line. And here's my port right in the middle of it. Let me draw my port right there. So ship A sails with a bearing of 68 degrees east of north. So if this is north, so 68 degrees east of that would be kind of in this direction, to where this is a 68-degree angle, and that is ship A. So let me put a dot here, and let's say that here is ship A. Ship B sails with a bearing of 30 to 35 degrees east of south. So they both leave port. So here is south. So 35 degrees east of that, let's see, would be somewhere right in there, to where again, this is a 35-degree angle. 35 degrees east of south, where if this is south, there's 35 degrees east of it. If this is north, that was 68 degrees east of it. Okay, that's ship B. If the ships maintain their paths, how far apart will they be at 2 p.m.? So we're looking for this distance right here. Okay, first thing we got to do is some little basic math. First off, if this is a 35-degree angle and this is a 68-degree angle, if you add that together, that gives you a 103-degree angle. So that means that this angle inside of here would have to be a 77-degree. Those three angles will have to add up to 180. The other thing that we've got to work on, they set sail at 8 a.m., and we want to know how far apart will they be at 2 p.m., which is going to be 6 hours later. That's the reason they gave us speeds. Ship A is going at 17 miles per hour for 6 hours. We've got to see, okay, from here to here, how far has it traveled? 17 miles per hour for 6 hours. That would be 102 miles. Same thing we got to do for ship B. Started here, ended up here. It is, let's see, it's sailing at a speed of 12 miles per hour, so it has traveled 72 miles. So now the rest of it's not important. Here, here, and here is the information we need. And we want to know how far apart are they. So that's we've got it set up. So therefore, we're going to let this, I guess this would be our C, since the other ones are A's and B's. So to figure out that missing side length, again, we're going to use the law of sine or cosines. We're looking for a C measure, so let's use our third law of cosine. Or again, we always had the option of just changing the letters if we wanted to. But our C value we're looking for, that's our unknown. Our small a value, if this is angle A or ship A, then our small a would be 72. Our small b would be 102. Minus 2 times 72 times 102 times the cosine of our angle, which is a 77-degree angle. Type all of this in, and we get x squared is equal to 12,283.9189. So x would equal the square root of that, which is 110.8 miles. And the next one, number 8. Bruno and Aliona are figure skaters. Starting from the same location, Bruno skates 29 feet at a bearing of 55 degrees and 9 minutes west of south. So let's go ahead and draw our north-south line again. And they are starting, there's north-south. They are starting from the same location, which we'll put it right there. Bruno skates 29 feet at a bearing of 55 degrees and 9 minutes west of south. So west of south would be in this direction. So we need to take that 55 degrees plus 9 minutes, which would be 9/60ths, and change that to a decimal. And that would be 55.15 when we do that. So therefore, this is a 55.15-degree angle. Now, Aliona skates 18 feet at a bearing of 16 degrees 51. So 16 degrees plus 51/60ths east of south. So therefore, that would be in this direction. So this angle right here, now let me erase this and draw it better. That would be, this angle over here was 55.15. Draw it bigger so we can see it. And then 16 plus 51/60ths, that would be 16.85 degrees. So this angle over here would be 16.85 degrees. Let's see, the first person skated 29 feet. The second, let me draw that in a different color since it's important. 29 feet. The second person skated a total of 18 feet. How far are they apart? So what is the distance from here over to here? Now this whole angle is what we're going to need. So we can add these two angles together, and this whole green angle right here is going to have a total of, let's see, 55 and 16. That's going to be 71, and 1 will be 72 degrees is going to be your angle. So now you can let the letters be anything you want. We'll say this is A, this is B, this is C. Doesn't really matter. So now we're going to use the formula that involves angle A. And there it is. And we are looking for this unknown down here. Let me erase that S. We're looking for this value. So we got x squared equals, our B value is 18. So 18 squared plus 29 squared minus 2 times 18 times 29 times the cosine of our angle, which is a 72-degree angle. Again, all we have to type in is these three terms, and you get x squared is equal to 842.3863. Take the square root of that, and you're going to get right at 29 feet. Okay, the last one. Says a helicopter spots 2 landing pads below. The straight line distance from helicopter to the pads is 14 miles to landing pad A, 8 miles to landing pad B. If the landing pads are 20 miles apart, find the angle of depression from the helicopter to landing pad B. So we've got a helicopter here. Then we have 2 landing pads. Landing pad A and landing pad B. Now let's draw here. There we go. It says that the straight line distance from helicopter to the pads is 14 to A, 8 to B. So therefore, this would be 14, and this would be 8. It says that the landing pads are 20 miles apart, so that makes this 20. Find the angle of depression from the helicopter to landing pad B. So that might seem a little bit tough, but let me remind you, the angle of depression, if this is your helicopter, this is your angle of depression. And a reminder that an angle of depression is the exact same value as the angle of elevation. So this angle of depression and this angle of elevation is the same thing. So they wanted to see if you remembered, okay, do you remember what an angle of depression is? Because if you remember that it's the same as the angle of elevation, all you're finding is angle B here. So now let's go through. We're looking for, let's use our formula. And if you want to call this C instead of H, you can say C stands for copter or something. So let's go ahead and use our formula that involves angle B, or you can just change all the letters. It doesn't matter. And here it is. And now let's simply plug everything in. Small b is 14. So you have 14 squared equals, small a is 8, small c is 20. Now again, this could have been worked by solving this formula for angle B. Would have been a little bit easier, but the steps are the same. Let's move these two terms over. So you now have 14 squared minus 8 squared minus 20 squared. So those are gone. Since these are being multiplied by the cosine of B, let's divide by -2 times 8 times 20, and that's going to equal the cosine of B. Now, if you wanted to, you could actually go ahead and move this cosine over as well. You can either type all of this in and then move it over, or you can just do the inverse cosine as you're typing it in. But you're going to get either way, the cosine of B is equal to 0.8375. And then once you find the inverse cosine of 0.8375, you get that angle B is equal to 33.1 degrees. So therefore, this angle is 33.1, which means, again, this angle is also 33.1 degrees.